Welcome to another section of online class Continuity and Differentiability Problem Section 3. Here we have a question f of x equal to 3 if 0 less than or equal to x less than or equal to 1, 4 if 1 less than x less than 3, 5 if 3 less than or equal to x less than or equal to 10. First of all, let's find the domain of this function. Here we can see that this function is defined for all real number between 0 and 10 including both. Therefore, the domain of the function is 0 closed interval 0, 10. Therefore, we have to check the continuity of the function between 0 and 10. Here we can see that 3 is a constant function. Therefore, in between 0 and 1, this function is a constant function. Therefore, it is continuous. Similarly, between 1 and 3, the function is another constant function, that is 4, that is also continuous. Between 3 and 10, the function is 5, that is also continuous. So we have to find this. We have to check the continuity of the function at x equal to 0, because it is starting point of the closed interval, at 1, at 3, at 10. First of all, we can check the continuity at x equal to 0. At x equal to 0, here you have to remember one thing, this is the starting point of the closed interval. We already know that continuity in a closed interval AB means it is the right limit is equal to value of the function. Therefore, there is no need of finding right left limit at x equal to 0. Here I am finding limit a. First of all, I am finding f of 0. F of 0 is equal to 3 because x equal to 0 is 3. I am finding limit f of x tends to 0 plus. There is no need of finding left limit. We have to find the right limit only. That is, limit x tends to 0 and it is greater than 0. Therefore, we have to take this function here. That is 3. Therefore, right limit is equal to f of 0. Therefore, f is continuous at x equal to 0. Therefore, we proved f of x is continuous at x equal to 0. Now we have to examine the continuity at x equal to 1. For that, f of 1 is equal to 3. Now, limit f of x tends to 1 minus, that is equal to less than 1, the function is 3. Limit f of x tends to 1 plus, that is right limit, is equal to greater than 1 and tending to 1, that is 4. Here we can see that value of the function is 3, left limit is 3, right limit is 4. They are not equal. Therefore, f is discontinuous at x equal to 1. So there is a point of discontinuity at 1. Now we have to examine the continuity at 3. At 3. That means at x equal to 3. At x equal to 3, f of 3 is equal to x equal to 3, it is 5. Now, limit f of x tends to 3 minus, that means left hand limit, x is tending to 3 and less than 3 is 4. Limit f of x tends to 3 plus, that is equal to x is tending to 3 and it is greater than 3, the function is 5. Therefore, here again value not equal to left limit, not equal to right limit. These three are not same. Therefore, f is discontinuous at x equal to 3. Now we have to examine the continuity at x equal to 10. Here we have to remember one thing. At x equal to 10, value of the function is f of 10 is equal to 5. Here we have to remember, this is the end point of the closed interval 0, 10. Therefore, there is no need of finding right limit. We have to find only left limit. The left hand limit of the function is limit of x tends to 10 minus. That means x is going to 10 and it is less than 10. The function is 5. Left limit is 5. That is equal to f of 10. Therefore, f is continuous at x equal to 10. Therefore, we can conclude this function is continuous at 0, discontinuous at 1, discontinuous at 3, continuous at 10. Here is another question. F of x equal to 2x if x is less than 0, 0 if 0 less than or equal to x less than or equal to 1, for x if x greater than 1. We have to discuss the continuity of the function. Here we can see that 2x is a polynomial function, therefore it is continuous if x is less than 0. Similarly, 0 is a constant function, that is also continuous. 4x is a polynomial function, that is also continuous. We have to examine the continuity at the point 0, 1, 0 and 1. First of all, at x equal to 0. At x equal to 0, the value of the function is f of 0 is 0. Now limit f of x tends to 0 minus, that means x is tending to 0 and it is less than 0. We have the function limit 2x, x tends to 0, because if x is tending to 0 and it is less than 0, it is 2x. That is 2 into 0 equal to 0. The left limit is equal to 0, value is equal to 0. Now limit f of x tends to 2 plus 0 plus, that is equal to limit x tends to 0. X is tending to 0 and it is greater than 0 means we have to take this one, that is equal to 0. Therefore, value equal to left limit equal to right limit. Therefore, f is continuous at 0. Therefore, we can write f of x is continuous at 0. X equal to 0. Now we have to check the continuity at 1. At x equal to 1. At x equal to 1, f of 1 is, if x equal to 1, the value of the function is 0. Now limit f of x tends to 1 minus, that means x is tending to 1 and it is less than 1, the value of the function is 0. Limit f of x is tending to 1 plus, that is right limit, it is equal to x is greater than 1 is limit to 4x, x tends to 1, that is equal to 4. Here left limit is not equal to right limit, therefore f is discontinuous at x equal to 1. Therefore, there is no, here we can see that this function is defined in set of all real number, that is discontinuous at x equal to 1. Here we have to discuss the continuity of the function f defined by f of x equal to minus 2 if x less than or equal to negative 1. 2x if minus 1 less than x less than or equal to 1. 2 if x is greater than 1. Here we can see that this function is defined for all real number. Less than negative 1, it is minus 2, it is a constant function, therefore it is continuous. Between minus 1 and 1, it is 2x, it is a polynomial function, hence it is continuous. If x is greater than 1, it is another constant function 2, hence it is continuous. Therefore, we have to discuss the continuity of the function at x equal to negative 1 and 1. First of all, at x equal to negative 1. F of negative 1 means it is minus 2, negative 2. Now we have to find the left limit at negative 1. That means limit f of x tends to negative 1 minus. We can see that if x is tending to negative 1 and less than negative 1, the function is minus 2. Therefore, it is limit x tends to negative 1 minus 2. That is equal to minus 2. Also, the right hand limit at x equal to negative 1 is limit f of x, x tends to minus 1 plus. That is limit x tends to minus 1, right hand side of negative 1. That means x is tending to negative 1 and greater than minus 1, the function is 2x. Therefore, we have to use this function 2x. That is limit x tends to minus 1, 2x equal to 2 into negative 1. That is also minus 2. Therefore, value of the function at minus 1 equal to left hand limit equal to right hand limit. So, the function is continuous at x equal to negative 1. Now, we have to examine the continuity at x equal to 1. First of all, we are finding f of 1. That is 2 into 1. That is equal to 2. Now, limit f of x, x tends to 1 minus, that is left hand limit. That is equal to limit x tends to 1. If x is tending to 1 and it is less than 1, the function is 2x. Therefore, we have to take this function 2x. That is limit x tends to 1, 2x. That is equal to 2 into 1, again 2. Now, right hand limit. Limit f of x, x tends to 1 plus is equal to limit x tends to 1, 2. That is also equal to 2. So, the function is continuous at 1. Hence, we can say that this function is a continuous function throughout the domain. That means it is continuous for all real number. It is given that f of x equal to ax plus 1 if x less than or equal to 3, bx plus 3 if x is greater than 3 is continuous at x equal to 3. We are able to find the relation between a and b. Here it is given that it is continuous at x equal to 3. Therefore, we can write f of 3 is equal to a into 3. That is 3a plus 1. That is value of the function at x equal to 3. Also, we can find limit f of x tends to 3 minus. That is equal to limit ax plus 1. X tends to 3. That is equal to 3a plus 1. Now we can find it. Now, the right limit is limit x tends to 3 plus f of x. That is equal to limit x tends to 3 bx plus 3. Because x is tending to 3 and greater than 3 means bx plus 3. That is, we get 3b plus 3. Here, given that function is continuous at function is continuous at x equal to 3. That implies left limit equal to right limit equal to value. That means 3a plus 1 is equal to 3b plus 3. That is, we get 3a minus 3b is equal to 2. That means a minus b, 3 into a minus b equal to 2. That is, we can write a minus b is equal to 2 by 3. Or a equal to b plus 2 by 3. Therefore, this is the relation between a and b. ഇനി നമുക്ക് ഇപ്പോൾ ചെയ്ത പ്രോബ്ലത്തിൻ്റെ ഗ്രാഫ് എന്താണെന്ന് നോക്കാം. നമ്മുടെ ഫംഗ്ഷൻ എന്ന് പറയുന്നത് എഫ് ഓഫ് എക്സ് ഈക്വൽ ടു എ എക്സ് പ്ലസ് 1 ആൻഡ് എഫ് ഓഫ് എക്സ് ഈക്വൽ ടു ബി എക്സ് പ്ലസ് 3. That means for all real number less than or equal to 3, the function is ax plus 1. For all real number greater than 3, the function is bx plus 3. Now, we can see that if a changes like this, the first function changes like this. Similarly, if we change b like this, Here the second function changes like this. Now if you take at this point, that means a equal to b plus 2 by 3 വരുന്നുണ്ടെങ്കിൽ ആ സമയത്ത് നമുക്ക് ഈ രണ്ട് ഫംഗ്ഷനും കൂട്ടിമുട്ട, അതായത് കണ്ടിന്യൂസ് ആവുന്നതായിട്ട് കാണാൻ പറ്റും. അപ്പം എ പ്ലസ് എ ഈക്വൽ ടു ബി പ്ലസ് 2 by 3 സാറ്റിസ്ഫൈ ചെയ്യുന്ന പോയിന്റ്സ് സാറ്റിസ്ഫൈഡ് ആണെങ്കിൽ നമുക്ക് ഈ രണ്ട് ഫംഗ്ഷനും കണ്ടിന്യൂസ് ആവുന്നതായിട്ട് കാണാൻ പറ്റും. ഇവിടെ ഞാൻ എയുടെ വാല്യൂ 60 എടുത്തിട്ടുണ്ട്. ഞാനിവിടെ എയുടെ വാല്യൂ 0 എടുത്തിട്ടുണ്ട്. പിയുടെ വാല്യൂ -0.66, ഓൾമോസ്റ്റ് 0.66 വരികയാണെങ്കിൽ നമുക്ക് ഈ രണ്ട് ഫംഗ്ഷനും തമ്മിൽ ഈ ഫംഗ്ഷൻ കണ്ടിന്യൂസ് ആവുന്നതായിട്ട് കാണാൻ പറ്റും. അതിനർത്ഥം ബി ഈക്വൽ ടു -2 by 3 ആയിരിക്കും. അപ്പോൾ ഈ ഒരു റിലേഷൻ സാറ്റിസ്ഫൈ ചെയ്യുകയാണെങ്കിൽ രണ്ട് ഫംഗ്ഷനും കണ്ടിന്യൂസ് ആവുന്നതായിട്ട് കാണാൻ പറ്റും. ഹിയർ ഇസ് അനദർ ക്വസ്റ്റ്യൻ. ഫോർ വാട്ട് വാല്യൂ ഓഫ് ലാംഡ ദ ഫംഗ്ഷൻ ഡിഫൈൻഡ് ബൈ f of x equal to lambda into x square minus 2x if x is less than or equal to 0, for x plus 1 if x is greater than 0 is continuous at x equal to 0. Also, what about the continuity at x equal to 1? First of all, we can find f of 0. We have to check the continuity at 0. That means f of 0 is equal to lambda into 0 square. Instead of x, we are writing 0. 0 square minus 2 into 0. That means lambda into 0, that is equal to 0. Therefore, value of the function at x equal to 0 is 0. Now, left hand limit at x equal to 0. That is limit f of x, x tends to 0 minus. That is equal to limit x tends to 0, lambda into x square minus 2x. Now, if you put x equal to 0, we get lambda into 0, that is also 0. Therefore, left hand limit at x at 0 is 0. Now, right hand limit at 0. That is limit f of x, x tends to 0 plus. That is equal to limit 4x plus 1, x tends to 0. That is 4 into 0 plus 1, that is 1. Therefore, we get f of 0 equal to 0. Left hand limit at 0 is 0. Right limit at 0 is 1. Now, we can take f is continuous at x equal to 0. That implies limit f of x, x tends to 0 minus, that is left hand limit at 0 equal to limit f of x, x tends to 0 plus. That means right hand limit. That is left hand limit equal to right hand limit. Left hand limit is 0, right hand limit is 1. Therefore, 0 equal to 1. That is not possible. That is impossible. Therefore, we can write for no value of lambda, the given function is continuous at x equal to 0. അതായത് നമ്മളിപ്പം ഈ ഒരു പ്രോബ്ലത്തിൽ 0 എന്ന് പറയുന്ന പോയിന്റിൽ ഫംഗ്ഷൻ കണ്ടിന്യൂസ് ആവണമെങ്കിൽ അറ്റ് 0യിലുള്ള ലെഫ്റ്റ് ലിമിറ്റും റൈറ്റ് ലിമിറ്റും ഈക്വൽ ആവണം. ലെഫ്റ്റ് ലിമിറ്റും റൈറ്റ് ലിമിറ്റും ഈക്വൽ ആവുക എന്ന് പറഞ്ഞാൽ നമ്പർ 0, അതായത് 0 എന്ന് പറയുന്ന ഇൻറ്റിജറും 1 എന്ന് പറയുന്ന ഇൻറ്റിജറും ഈക്വൽ ആവണം. അതൊരിക്കലും സാധിക്കാത്ത, അതായത് ഇമ്പോസിബിളായ കാര്യമാണ്. അതിനർത്ഥം നമുക്ക് ലാംഡയ്ക്ക് ഏത് വാല്യൂ കൊടുത്താലും നമുക്ക് ഈ ഫംഗ്ഷനെ കണ്ടിന്യൂസ് ആക്കാൻ സാധിക്കുകയില്ല. Now we have to examine the continuity at x equal to 1. Here at x equal to 1, value of the function is f of 1, that is 4 into 1 plus 1, that is equal to 5. Now we have to find the limit x tends to 1 f of x. That means limit at x equal to 1. Here we can see that in the left hand side of 1 and right hand side of 1, that is close to 1, the function is 4x plus 1. Therefore, there is no need of finding left limit and right limit separately. Therefore, we can find the limit f of x, x tends to 1 directly. That is limit 4x plus 1, x tends to 1. That is 4 into 1 plus 1, that is equal to 5. The value at f1 equal to limit at 1. That means value of the function at x equal to 1 equal to limit f of x tends to 1. So the function is continuous at x equal to 1. ഈ ഫംഗ്ഷൻ x equal to 1 ഒരു പോളിനോമിയൽ ഫംഗ്ഷൻ ആയതുകൊണ്ട് നമുക്ക് കണ്ടിന്യൂസ് ആണെന്ന് പറയാൻ സാധിക്കും. നമ്മൾ ചെയ്ത ഈ പ്രോബ്ലം ഗ്രാഫിക്കലായിട്ട് കറക്റ്റ് ആണോ എന്ന് ഒന്ന് ചെക്ക് ചെയ്ത് നോക്കാം. നമുക്കറിയാം for all real number less than 0 the function is lambda into x square minus 2x. This is the graph of lambda into x square minus 2x. Here I am taking lambda is equal to 0.4. Now if you change lambda, this curve changes like this. For different lambda, this curve is like this. Here lambda is equal to 1, here lambda is equal to 2, 0.3, etc. For different lambda, this graph is like this. Now also for all real number greater than 0, the function is 4x plus 1. 4x plus 1. This is the graph of 4x plus 1. Now, if you take any lambda, if you put any lambda, we cannot make this function as continuous. അതായത് നമ്മളിപ്പം ലാംഡയ്ക്ക് ഏത് വാല്യൂ കൊടുത്താലും നമുക്ക് ഈ ഗ്രാഫിനെ കണ്ടിന്യൂസ് ആയിട്ടുള്ള ഒരു ഗ്രാഫാക്കാൻ സാധിക്കില്ല. അപ്പോൾ അത് നമുക്കൊരു കാര്യം മനസ്സിലാക്കാം, ലാംഡയ്ക്ക് ഒരു വാല്യൂ എക്സിസ്റ്റ് ചെയ്യുന്നില്ല എന്ന് മനസ്സിലാക്കാം. ഇനി ഈ ഒരു പോയിന്റ് ചെക്ക് ചെയ്യുക. ഇവിടെ x equal to 1 ആണ്. ഇവിടെ ഫംഗ്ഷൻ്റെ ലെഫ്റ്റ് ലിമിറ്റും റൈറ്റ് ലിമിറ്റും വാല്യൂ ഈക്വൽ ആണ്. അത് 5ന് ഈക്വൽ ആയിരിക്കും. അതുകൊണ്ട് ഇവിടെ കണ്ടിന്യൂസും ആയിരിക്കും.